my biased ranking of US units of measurement. First up, a classic flop, feet. Not too much to say here. Some people arguably like this unit a bit too much, but it is a rather intuitive measurement thanks to the fundamental desire for humans to use body parts to make measurements. Anyway, my foot happens to be about 12 inches, so I'll be generous here, C tier. Back to another classic L of a unit, inches. In many European languages like French shown here, inch translates to the same word that thumb translates to, and that's no coincidence. King David I of Scotland declared the inch to be the width of a man's thumb at the base of the nail. However, they were incredibly smart and realized that everyone's thumb was actually a different size. So in a genius move, they measured a staggering 3 different men and averaged the measurements. Absolutely innovative, D tier. Next up, the ounce, and I'll also group it with the fluid ounce. Ounce is a force while fluid ounce is a volume. They're basically the same, with the important caveat being that it only applies to water at very specific conditions. To be fair though, water is pretty important, so it's somewhat reasonable. However, dissolving stuff in water does change the density. So for example, 12.5 fluid ounces of soda doesn't weigh 12.5 ounces in weight, but rather a little over 13.5 ounces, which is pretty infuriating. F tier. Next up, Fahrenheit, a unit of temperature which I'll actually declare as underrated. Not necessarily good, but underrated. I know some people's blood is probably starting to boil, perhaps at around 212 degrees Fahrenheit, but that's probably because you've been traumatized by actually trying to use this unit for calculations, but hear me out. Like all of us, Daniel Gabriel Fahrenheit was obsessed with thermometers, and he was pretty goated at it. He'd make multiple thermometers that would have the same reading, which I know sounds trivial, but was actually very difficult at the time. He of course needed to add markings to his thermometers, and there's a bunch of different stories as to how these values were selected, and like all units, they evolved over time. One tale supposes he marked around 100 degrees to be what he measured to be the human body's temperature, and 0 was just marked as the coldest temperature that he measured outside during the winter of 1708. Other accounts say that's perhaps how 0 was first defined, but he needed it to be more legit, so he created this temperature in the lab by cooling a salt mixture to as low as possible and labeling that temperature 0. Regardless of the validity of these stories, it's funny that it just stuck, and the Fahrenheit scale isn't as bad as it seems, only because of how frequently we humans talk about the weather on Earth, where 0 is uncomfortably cold and 100 is uncomfortably hot. So it's essentially just rating how hot you're going to be on a scale of 0 to 100. Sure, there's some non-linearity, but that's kind of cool. Anyway, if water cooler weather talk was the only context temperature was ever used in, I'd rank it even higher. But it's not, so C tier. Next up, the mile. The reason for defining the mile was pretty logical. Basically, they wanted a unit for the distance a human could reasonably travel in about 1,000 paces. Through standardization later, this 5,000 feet approximation was changed to its current definition of being exactly 5,280 feet. When I jogged a mile on a modern day track, I counted a little over 1,200 steps, but maybe if I was in better shape, I could have gotten closer to 1,000. C tier. Next up, the ton. This is a unit of weight, even though people also use the word to just mean a lot of something. 1 ton is very heavy though, at 2,000 pounds, so I'm okay with that. By the way, this unit is not to be confused with the metric ton, which when converted is about 2,200 pounds. C tier. Next up, an absolute sleeper of a unit, tons of refrigeration. Tons of refrigeration has nothing to do with the weight of a refrigerator or how many refrigerators you have. Back in the days when people had literal ice boxes to keep food cold and ice was cut out of frozen bodies of water and shipped using boats and railroads, a ton of refrigeration/cooling was a standardized unit of power equivalent to the amount of cooling that could be provided by melting a 1-ton block of ice in a 24-hour period. Once vapor compression systems replaced the ice trade, this unit stuck around and is still commonly used to size air conditioning systems. B tier. Next up, the acre. An acre was once defined as the amount of land that a yoke of oxen could reasonably plow in one day's work using a wooden plow. That's still one of the most important features when choosing to buy a house, which is why Zillow often still uses this unit. D tier. Next up, horsepower. James Watt was having trouble getting people to adopt steam engines instead of horses to do work, so he made a very approximate estimation for how much power a horse can generate and called it 1 horsepower so people could envision how useful the engines were. Most horses can actually generate substantially more power than 1 horsepower, at least in short periods of time, so it's not perfect, but still pretty cool. B tier. Next up, a rather unique one, American wire gauge. This one refers to the diameter of solid wire, and as you might expect, a larger wire gauge corresponds to a smaller diameter wire. The reasoning for this has to do with how wire was manufactured. For example, 20 gauge wire would have to pass more times through dies than say 0 gauge wire. And no, 0 gauge wire is not the largest wire. There's also 00, 000, and 0000 gauge wire. Perhaps if someone could better explain to me the rationale for the numbers or the rules of thumb, I could upgrade my rating, but for now, F tier. Next up, the yard. The exact origin of the yard is uncertain. One story says that it was based off the distance of a large step, like how soccer refs use it to set the distance of the wall during free kicks. King Henry I also declared that it was the length of his arm. Regardless, a yard is nowhere near the size of an average yard, so F tier. Next up, another classic, the pound. We commonly use this unit to judge ourselves on a scale, but that's only half the story. There's actually 2 units for pound: pound force, like the reading on the scale, and pound mass. The original unit pound was actually created before gravity was discovered, so people didn't even know that mass and force were different at the time. Mass is the amount of matter you're actually made up of and doesn't change based on where you are. You know, the whole conservation of mass principle. When you multiply your mass by the acceleration due to the gravitational field you're in, you get your weight in pounds force. In standard gravity on Earth, based on the definition of each, 1 pound of mass weighs 1 pound of force. That's why people got away with using just a single unit to refer to mass and weight interchangeably. Basically everything was done on Earth in roughly standard gravity. However, if you went to the moon, for example, 1 pound of mass in the weaker gravitational field of the moon would weigh about 0.16 pounds of force, which is an absolute headache, and without a cool origin story that I could find, I'm placing both of these units in F tier. Next up, inches of water, which is a unit of pressure. Both of these containers have about 1 inch of water in height, so the gauge pressure at the bottom of each water column is the same. Pressure is equal to the force divided by the area, force is the mass times the acceleration due to gravity, and then the mass is the density times the volume. Now with this, you can pull out the density and the acceleration due to gravity and see it's a ratio of volume over area, which when you divide the formulas for each, you see that it gets simplified just to a single length. So for example, 407 inches of water is the pressure that a 407-inch water column provides, assuming standard density and standard gravity. That's absolutely critical. Since this is just the height of the column, inches of water can easily be converted to any other unit of length, like feet of water or miles of water. I chose 407 inches in this example because this happens to be atmospheric pressure, which is caused by the weight of the air in the atmosphere. Measuring pressure as the length of a liquid column is a pretty cool way to visualize pressure, especially in fluids. But making really tall water columns just to measure larger pressures is impractical. To get around this, the much denser liquid mercury was often used. Back to our example, 407 inches of water is equivalent to about 30 inches of mercury, which still isn't great, but it's definitely better. D tier. Next up, BTUs, aka British thermal units. A BTU is the amount of energy needed to raise 1 pound of water 1 degree Fahrenheit, which seems rather clean, except for the fact that, as you know, pound and Fahrenheit are already ridiculously arbitrary. To make matters more confusing, it's commonly accepted in industry to shorten the unit of power BTUs per hour to just be BTUs, and it's assumed to be per hour. D tier. Next up, thou, also known as 1/1000th of an inch. This unit is commonly used when machining parts. I mainly included this unit just to say that I'm thankful it's used over the obsolete twip, which is 1/1440th of an inch. Converting thou to inches simply by moving the decimal over rather than another arbitrary conversion is absolutely genius, and it would be cool if there was a whole unit system based around this principle. Anyway, thou is still based on an inch though, so I have to put it in the same ranking, D tier. Next up, degrees Rankine. Rankine is the same temperature scale as Fahrenheit except shifted 459.67 degrees. That might seem random, but this shift is such that 0 degrees Rankine is absolute zero, the coldest temperature possible. This makes Rankine usable for some calculations that Fahrenheit can't be used for, but it loses the simplistic usability for weather that Fahrenheit had, so D tier. Next up, the slug. The slug is a unit of mass equivalent to 32.2 pounds of mass, which is the mass of about 48,000 average-sized garden slugs for those curious. Remember the whole pounds mass and pounds force debacle earlier? Well, using slugs instead of pounds mass does virtually nothing to make things better, other than provide another arbitrary unit conversion. The actual way it's defined is if you push an object with a constant 1 pound of force and it accelerates at a constant 1 foot per second squared, then the object has a mass of 1 slug. And similar to BTUs, just because you use a lot of ones in the definition doesn't make it more simple to use in practice. I guess you could say the one potential benefit of slugs is that it's immediately clear that you're referring to mass, but I'm even skeptical of this given its name. When I say I'm 6.2 slugs, that just doesn't sound right. So I'm almost tempted to specify I'm 6.2 slugs in mass, which loses the entire tiny upside of this unit over pounds of mass. F tier. Last up, teaspoon, tablespoon, cup, pint, quart, and gallon. I grouped all of these together because they're most often used in cooking and are really intuitive. You wouldn't use a big spoon like this for tea, you'd use it at the table, as a tablespoon. For tea, you'd use a smaller spoon like this teaspoon. There's 3 teaspoons in a tablespoon. A cup is 16 tablespoons, which unfortunately is a little bit less water than I'm looking for if I ask for a cup of water. Anyway, then there's 2 cups in a pint. 2 pints in a quart, and then 4 quarts in a gallon. That one makes sense. I hate them all, so F tier. And there you have it, my final tier list. I definitely spent way too long on this video, but I hope you enjoyed hearing some of the interesting backstories, and if you did enjoy this video, please hit the like button and share with anyone who might also be interested. If you're new to my channel, I'd love for you to check out some of my other videos. Here's one linked right on the screen. Thanks for watching to the end, and I'll see you next time.